in this given example, there is one source of 24 volt and 3 resistor, and two mesh current I1 and I2 are given. So as we discussed, like in first step, we have to assign current on each passive element. So like here, this I1 is flowing from 24 to 20, then 20, then again it will come back to 24 volts. So if I assign current, so it will be like this. And here at this node, in this particular loop, current will be like I2. So after assigning the current, our loop look like this, where current I1, I2, and in the common branch there will be current I. Now what will be the I? So it can be seen like I1 is flowing in this direction and I2 is flowing in the opposite direction. So here current would be I1 minus I2. But let's say if you are confused how exactly it will be, so what you can do is you can redraw this circuit like this, and here you can apply Kirchhoff's current law, and what it states, like incoming current equal to outgoing current. So here incoming current is I1, which will be the sum of outgoing current. So in this case I and I2. So I would be I1 minus I2. So here this current is I1, outgoing current is I2, and this I is I1 minus I2. So after assigning this current, redraw the circuit like this: I1, I2, I1 minus I2. Now here this I1 is flowing through this 20 ohm resistor. Let's say this is 20 ohm and I1 is flowing. So as we know that current will flow from higher potential to lower potential, so of course here this potential will be higher as compared to other terminal. And as this is 20 ohm and current flowing through this 20 ohm is I1, so there will be a drop of 20 I1. Okay, this we have discussed for this particular. Similarly we can do it for this 20. So here drop will be 20 I2 and here it will be 20 I1 minus I2. So after assigning all those signs and voltage drop, we can redraw circuit like this. So 20 I1, 20 I2, 20 I1 minus I2. Now we have to apply Kirchhoff's voltage law. So if I start applying from point, so minus to plus, so it means plus 24, and plus to minus means 20 I1. Then here plus to minus, so minus 20 I1 minus I2. That is for loop number 1. And for loop number 2, if we go in this direction, so minus to plus, so plus 20 I1 minus I2, and plus to minus, so minus 20 I2 will be equal to 0. So those two equations, if I further simplify it, so I1 20 I1 plus 20 I2 will be equal to 0. So 24 minus 40 I1 plus 20 I2 will be equal to 0. So 40 I1 minus 20 I2 will be equal to 24, which is equation number 1. And 40 I1 minus 20 I2 minus 20 I2 is equal to 0. So 20 I1 minus 40 I2 will be equal to 0. That would be equation number 2. Now if I write this equation 1 here, so we have to eliminate one element, like either I can eliminate I1 or I2. So let's do it for I1. So what I will do is I will multiply this equation 2 with 2. So this 20 will becomes 40 I1, and here this 40 will become 80, and then minus plus minus, that would become 60 I2 would be equal to minus 60, right? So minus 60 I2 will be minus 24. So minus 60 I2 equal to minus 24. So I2 will be 24 over 60. So that would be is nothing but 0.4 ampere. So that would be 0.4, and if I substitute this 0.4 ampere in one of the equation which was derived, like let's say if I substitute in this 40 I1 minus 20 I2 is equal to 24. So 40 I1 is a subject, so 24 plus 20 I2. I1 would be 1 over 40. 24 plus 20 times I2 means 0.4. That would be 24 plus 8. So 1 over 40. 24 plus 8 is 32. So 32 divided by 40 is 0.8. So I1 is 0.8. So here this current is 0.1 equal to 0.8 and I2 is equal to 0.4. And this current I, which I1 minus I2, so 0.8 minus 0.4 will be nothing but again 0.4 ampere. So that we can